Hello, it's time for another math easy solution. Today we're going to discuss what pi is and prove that it's a constant that equals 3.14 and keeps going on and on. Well, what is pi? Well, we'll start by drawing a circle and we'll have a diameter d, and there's the circumference c, which is just a perimeter around. That's c, and then what we'll get is, now by definition, pi is defined as c over d. Pi is equal to circumference divided by diameter of any circle, and this magically equals to a number like 1.59265. It keeps going on. It's irrational, meaning it never repeats and it keeps going on forever. And this is very important in mathematics because this applies to any circle. If you have small, big, doesn't matter. The ratio of a circumference to diameter is always going to be equal to pi, which is 3.1459. Keeps going on. And this is used throughout math. And yeah, you'll probably see this many times. And it's one of the most important and well-known constants in all of math. So let's prove this. Well, a simple proof that I just figured out now is using a geometric proof. And that is, well, I just pasted this giant circle because I didn't want to draw all these, so it would have looked too messy. So you have this. So what you would do is now look at the perimeter of let's say this inside square and compared with the circumference c, which equals to, if you rearrange that, pi times d, which equals to 2 pi r, because d is equal to 2r. So you have a radius. This is radius r. Let's start with this square. We're going to compare the parameters. The perimeters of this square, and you'll see that as you keep adding sides, it's going to equal this number, the ratio. It's going to equal the circumference. So what we'll get here, this is an angle 45. This is, by geometry, this is a perfect square. This is 45 here. And it's going to be 90. So yeah, it's just 45 degrees. By symmetry, this is r. Now this is equal to sine. This is this length. Equal to sine 45 degrees. This is degrees, not radians, which is shown in another video. Times r. And if you aren't familiar, we'll just draw a little thing here. This is a right angle triangle. This is adjacent. This is opposite. This is hypotenuse. And this is your angle theta. Theta is a Greek letter, and it's used as angle, and I'll use it as angle here too. So let's say sine is just a function which is defined with a variable this, which is angle, which just equals opposite over hypotenuse. It's just a ratio. And then if I rearrange it, you get opposite equals to h times sine theta. And in this case, h is equal to r, and theta is equal to 45 degrees. Alright, so now this entire side is gonna be equal to 2 times this, which is just sine 5 degrees. This is just by symmetry. This is a square. That's half a side of a square. So now perimeter of the square, we'll call this square, is going to be equal to 4 times the side, which is 4 times 2 sine 45 degrees times r. Alright, so now if we compare this c, which is the circumference of the circle, has to be greater than of the square, perimeter of the square, and you could just clearly see the perimeter here is going to be less than that. And then so if we add in the variables, we'll get 2 pi r is greater than 4 times 2 sine 45 degrees times r. Now if you cancel the 2, you can see 2 is cancelled, the r cancels, you're left with pi is greater than 4 times sine 45. Alright, and this so happens to be equal to, if you put in a calculator, we'll get 2.828, and keeps going on. And as you can see, this is less than what we were familiar with, 3.14. So now let's go to this polygon which has 8 sides. This one right here. This one has 8 sides. This is the red one. So if we draw this is 45 again. All the points of the squares is 45. And then if you cut it in half, because we want to get this side, this is 45. This is just cut in half, so 45 divided by 2 is the angle. And this is r again. And now this is just going to be, again, sine, this times 45 over 2 degrees times r. And then this side here is going to be 2 times this. So that's 2 times that. And now there's 8 sides. As you can see, there's 1, 2, 3, 4, 5, 6, 7, 8. So the perimeter now of the polygon, we'll call it P of poly, equals to 8 times 2 times sine 45 over 2 is the angle times r. Now if we equate the c over, we'll write 2 pi r. We'll just put these numbers in again. 2 pi r, which is the circumference of circles, greater than p of polygon. 8 times 2 sine, this is times 45 over 2 times r. So now this cancels, and the r's cancel again. The 2's cancel, r's cancel. Pi is greater than 8 times sine 45 over 2. If put in the calculator, we will get 3.061. I think it's that. So you can check if. But as you can see, we're getting closer and closer to this as we increase the size, and as you can see, it keeps getting closer and closer. And if you see, there's a pattern here that develops. We actually get, I'll just scroll down here. But what actually happens is, if we see the pattern here, we'll write it down. We'll have pi is greater than 4 sine 45 degrees, and pi is greater than 8. Now we doubled the sides. 45 degrees over 2. So we keep doubling it. What actually happens, if we keep doubling it, we'll just get pi 4 times n. And I'll show you what n is. N, this is just let's say we'll call this n equals 1, n equals 2, and then this keeps going on. We'll have, let's say, pi is greater than 16 sine 45 over 4. So this is n equals 4. I'm doubling everything, so n is going to keep going. It's going to be even except the first one. So sine 4, and then this is going to be 45 over n. And this is at n. Right, so n is just going to be equal to 1, and then all even numbers, 2, 4, 6, 8. It's even numbers because just by the way that I proved it here. So I just doubled every single time. So let's say if we were to put n is equal to 100. So we will get, actually, we will get pi greater than 4 times n, which is 100, times sine 45 over n, which is 100 degrees. Putting that in the calculator, you get 3.14156036. And if you compare that with the top, this is pi is actually equal to 3.14159.265. This keeps going on. So we got 4 decimal places close. So this is where we got close to. So if you keep increasing, if you go to, let's say n goes to, I don't know, infinity, we will get this number exactly. Well, it's not exact because it keeps going on and on. Well, there you have it. So that's the proof of pi as a constant equals 3.14. Hope you learned what pi is and learned a lot from this video, and hope you enjoy watching. And I'll tune in next time for another Math easy solution.